We have already learned how to visualize the shape of the data. That is the skewness. We knew that shape of the skewness can be visualized from the frequency polygon, histogram, or box plot. And you got there are three type of skewness: left tail or negatively skewed, right tail or positively skewed, or symmetric. That is can be visualized from the graph, but skewness of the data can be measured. We can mathematically calculate the shape of the data, and you know it is negatively skewed, that is left tail, right tail, or there is no symmetric. There are mainly two methods that is calculated by the coefficient of skewness. One is Bowleys coefficient of skewness, that is based on the quartiles, and second one is Pearson coefficient of skewness, or simply Pearson coefficient of skewness. This is based on mean, median, and standard deviation of the data. Let us know one by one what is Bowleys coefficient of skewness and Pearson coefficient of skewness. Bowleys coefficient of skewness, which is also known as Galton skewness. This is one of the measure of skewness which can be measured by quartiles. It is denoted by SKB, and the formula is Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1. We already know that Q1 is the first quartile, Q2 is the second quartile, and E is the third quartile. After doing the calculation by Bowleys coefficient of skewness, if you get the value, positive value, which is greater than 0, the distribution of data will be right tail or positively skewed. If you get the negative value of SKB, that is less than 0, the distribution will be left tail or negatively skewed. If SKB, that is Bowleys coefficient of skewness, equals 0 or near about 0, the distribution will be symmetric. So this is the formula to calculate Bowleys coefficient of skewness. Let us do a practical example. The daily internet used by the student in hours are given. From here, first of all, you have to calculate the quartiles, first quartile, second quartile, and third quartile. And from there, values, you have to calculate skewness by Bowleys coefficient of skewness. Then you have to make the comment. We already learned how to calculate the quartile wall, first quartile Q1 by this formula. And if you calculate it, you will get this 4.25 hours. Similarly, second quartile Q2 by this formula, we will get 10.5 hours. And third quartile by this formula, 15.5 hours. Okay. After putting all the values in the Bowleys coefficient of skewness, that is Q3 plus Q1 minus 2Q2 divided by Q3 minus Q1, that is the value, we will get minus 1.25 divided by 11.5, which will be minus 0.111. That is, Bowleys coefficient of skewness is negative, less than 0. So the distribution of data will be left tail or negatively skewed. So we know for the negatively skewed data, most of the data taking the higher values from the average. So if you take this diagram, that is, we can find that most of the data taking the higher values. That is, most of the students are using internet longer time. So this is the comment for negatively skewed data. Let us know or the second one, which is called Pearson coefficient of skewness, also known as Pearson coefficient of skewness, based on the mean, mode, median, standard deviation. When you know the mean, mode, and standard deviation, you can use SKP equal to mean minus mode divided by SD. Or if you don't know the mode, but you know the median, you can use the same formula, but that case 3 will be multiply mean minus mode and divided by SD. So interpretation is same as the Bowleys coefficient of skewness. If SKP greater than 0, distribution is right tail, or positively skew. If SKP less than 0, the distribution is left tail, or negatively skew. If SKP equal to 0 or near to 0, the distribution is symmetric. Let us see a practical example. These are the ages of the MBA student in a university. So from here, if you calculate the mean age or average age, we'll get it 32.64 years. Mode will be 37 years. Median will be 33 years, and standard deviation of age will be 6.66 years. So we know mean, median, mode, and standard deviation. You can use both form of the Pearson coefficient skewness. If you use the first one, mean minus mode divided by SD, put the value of mean minus mode SD, easier. No need to multiply by 3. You will get it is minus 0.055, negative value. And we know that when the SKP is negative value, the distribution will be left tail or negatively skewed. That is, you can say, so age, it will be the age, sorry. That is, you can say, when most of the students of MBA age are higher or older. So it will be more easier if you draw the, this is the left tail skew data in a whiteboard. Let us draw. We have a whiteboard. Okay, clean it. Okay. So if you draw a freehand, as our data is a left tail, so tail will be bigger on the left side. So here is the left side. So you can draw it. So if you have a line here, y-axis, and here is the age of the student. So as we know that our, what is the, if I know, say our student age started from 22 up to 40, yes, up to 40 or 45, 44, 45. So if you freehand draw it, as you say, so it started from suppose 20, 25, 30, 35, 40, 45, and here y-axis is the number of MBA student, okay, number of MBA student, a number of students, okay. If you just freehand draw, if you draw on the x-axis the age of the student and the y-axis number of student, just here maybe 10, 5 student, maybe 10 student, 15 student. So if you see the tail on the left side as a negative skew, if you see age is going to height 20, 25, 30, 35, what do you see? The height is the right side, but tail on the left side. That is, most of the student age are higher, older students. So we can comment from the data that as the age of the student are left tail, most of the student age are higher, they are older. So you can try for this data, Bowleys coefficient of skewness. You need to find out Q1, Q2, Q3. We know how to find out. First of all, you have to arrange the data ascending order. Then we have the formula. That formula used. Then you can try the skewness of the data by Bowleys coefficient of skewness. So these are the mathematical way by the coefficient, by two coefficient. One is Bowleys coefficient of skewness, and other is Pearson coefficient of skewness. Bowleys based on the quartiles Q1, Q2, Q3, and Pearson coefficient of skewness based on median, mode, mean, and standard deviation. Then you can know the shape of the data. It is left tail, negatively skew, it is right tail, or positively skew, or symmetric. That's all. So these are the way to know the shape of the data mathematically.